This is the lines and triangle unit vocab notes. We're looking at the first part, part one. We're going to start out with parallel lines, and this is a review from the last section. And parallel lines are two lines that never touch. So we can write that right in there. Two lines never touch, and they are on the same plane. And we're going to talk a lot about these two lines because they have a lot of interesting properties when we have another line cut through them and we form a bunch of angles. So the next one is where things get interesting. It's called a transversal. It's a line that cuts across parallel lines. So that line going through right there, you'll notice, is the one that's cutting across the parallel lines. Now we're going to see all the different kinds of angle pairs that we can form. So we form a lot of different angle pairs like alternate interior, alternate exterior, same side interior, same side exterior, and corresponding. So these next five are going to talk about that. So if we zoom in to alternate interior angles, let's sound out the parts. Alternate means opposite sides, and interior means inside. So we're opposite sides of something and yet we're interior to something else. So in this case we're going to be opposite sides of the transversal. So opposite sides of the transversal, but we are going to be inside the parallel lines. And then we are forming angles. So alternate sides of the transversal here, and yet interior to the parallel lines. So what that's going to look like for us would be a pair like number 4 and number 6. So angle 4 and angle 6. Those would be alternate interior. And in fact, it turns out they're actually equal. So we couldn't go ahead and say that angle 4 equals angle 6. So whenever we know we have parallel lines, we get that the alternate interior angles are equal. And it goes the opposite way. If we only knew that we at angle 4 and angle 6 were equal to each other, we would know that these lines must be parallel. So it's a biconditional. It's a statement that goes both directions. Another example, just to give a second example here, would be angle 3 and angle 5. So angle 3 is equal to angle 5 by alternate interior angles. Let's go ahead and jump down to the next one. Alternate exterior, same idea, except we are now exterior outside the parallel lines. So for example, we could have angle 2 and angle 8. And those are also going to be equal. So angle 2 is equal to angle 8. And you can kind of see that they appear to be about the same size. Another example would be angle 1 and angle 7. So angle 1 is equal to angle 7. So when we know that we have alternate exterior, we know that the angles are going to be equal. If we know the angles are equal, if we start here, then we get that the lines must be parallel. So if we start with parallel lines, we get equal angles. If we start with equal angles, we get parallel lines. Now same side, interior, and exterior. Same side refers to the same side of the transversal, in the same way that alternate meant alternate sides of the transversal. And this one is interesting. So interior means inside the parallel lines. So our example would be angle 4 and angle 5. Now you'll notice those two angles don't look like they are the same, and they are not. They are not the same. However, the two angles are actually supplementary. They add up to 180. So what we can say is angle 4 plus angle 5 is 180 degrees. And we know that because they are same side interior angles. Just like before, if we know that we have same side interior angles that add up to 180 degrees here, then we would get that these lines must be parallel. So it goes both ways here as well. Another example of same side interior in this picture would be angle 3 and angle 6. Next one, same side exterior. Same idea, but we are exterior to the parallel lines. So that means we would be looking out at angle 2 and angle 7. So angle 2 plus angle 7, and just like same side interior, they are going to be supplementary. So when they're on the same side like this, you'll notice that the angles don't look the same, but they do add up to 180. The other example, we have 8 and we have angle 1. So angle 1 plus angle 8 is equal to 180 degrees. Finally, corresponding. Now, corresponding is a little different than the other ones because we actually go to the exact same spot. So we might just write same spot, different line. Different line. And what that means is if we are starting with angle 2, the corresponding angle would be angle 6, and they will be equal. So angle 2 is equal to angle 6. Continuing around, we have corresponding angles right here, same spot, different parallel line. We have angle 1 is equal to angle 5. And we can work our way all the way around and say angle 4 equals angle 8. And our last one, angle 7, is equal to angle 3. So corresponding angles, they look the same, they're in the same spot, they are in fact actually equal. Generally with these, as long as your transversal is sufficiently slanted, you can usually eyeball it and tell whether or not they're going to be equal or supplementary. It's always going to be one of those two relationships that we're looking at when you have parallel lines. Next one is interesting, linear pair. We've talked about that in previous sections. One of the things about a linear pair is we don't need parallel lines to get it. We'll remember that we never talked about parallel lines before when we use linear pairs. It's when two sides are adjacent and supplementary. There are two angles, sorry, not two sides, two angles are adjacent, they are next to each other, and they are supplementary. They add up to 180 degrees. So in this case we could say something like angle 1 plus angle 2 is 180 degrees. We could also do 2 and 3, 3 and 4, 4 and 1, and then any of the ones below, any of the pairs below in the 5, 6, 7, 8. Vertical angles is another one that we reviewed, and it's opposite across from each other like angles 4 and 2 or angles 1 and 3. And unlike the one above that was supplementary, these with vertical angles are equal. However, similar to the linear pair, we don't need parallel lines to get it. So that's something that's just kind of, it might show up in these pictures, but it is not the parallel lines that makes it possible. So it is an extra unnecessary piece. So we could say that angles 1 and 3 are equal to each other. We could also say that angles 2 and 4 are equal to each other. And again, vertical angles, opposite corners of intersecting lines. And it does not need parallel lines to make it possible. Opposite corners of intersecting lines. And that's all for section 1.